this is the second part of section 1.4, and we're talking about the intermediate value theorem, or sometimes it will be referred to as IVT. Here's what the theorem is basically saying, is if I have a graph, it doesn't even have to be a graph, but if I have values, I'm going to pick a point. This is point A. So this is the height at point A. So this would be my y value, or another way to write that is f of A. And then I'm going to pick another point. I'm going to say point B. And here's point B. So that's f of B. That's my y value. Okay. Here is f of A. Here's f of B. The intermediate value theorem says somewhere between A and B, there is a value k. Okay, here's the height of A. There's the height of B. Somewhere between these two heights is a value k at some point. They call it point C. Okay, and they call this k. It seems like that should just be automatic, but here's the things that have to occur. It has to be a continuous function, okay, and it has to be on a closed interval. So you have to have a starting point and an end point. Another good example would be when you're 12 years old and you're 5'5", and then when you're 16 years old and you're 6 foot, somewhere between there, between the ages of 12 and 16, and between 5'5" and 6 foot, there has to be somewhere 5'7", 5'8", 5'9", something like that. That is the intermediate value theorem. So let's look and see. This is what it looks like mathematically. If f is continuous, so it has to be a continuous function. If it's not continuous, then the IVT theorem, this theorem does not apply. It has to be on a closed interval. It has to have an endpoint, two endpoints. Okay, my two endpoints cannot be the same value. K, which we just showed you, is any number between f of A and f of B, and there is at least one number C in which that happens. Okay, so here's what it looks like when we want to solve it. We want to verify that the intermediate value theorem applies to the indicated interval and find the value of C guaranteed by the theorem. It sounds hard, but it's really not. First thing we're going to do, here is our closed intervals. So we need to find the height of our graph at these 2 points. To do that, we're going to plug each one in. And first of all, we have to make sure this is a continuous function. X squared plus x minus 1, any x squared function is a parabola, and all parabolas are continuous. There's no breaks in them. So the first thing we're going to write down is, yes, f of x is continuous. These two numbers cannot be the same, and they're not. Okay, and now we are going to find our f of 0 and f of 5. So f of 0 equals, I'm going to plug 0 in place of all my x's. 0 squared plus 0 minus 1. That's negative 1. Now I'm going to find f of 5. So I'm plugging 5 in place of all my x's. So this is 25. 25 plus 5 is 30. 30 minus 1 is 29. All right, so what they're saying is, this number is also my height. This is my height. So this number has to be between these two things I just found. So the way we're going to write that is negative 1 is less than 11 is less than 29. Whoops. So I already know this is my low point, this is my high point. 11 is going to fall someplace in between those. I just have to figure out where, at what point, my height's going to be 11. So in order to do this, I'm going to take my original equation. I'm going to change colors here. I said change my equation. I'm going to take my problem they gave me and set it equal to whatever this was, 11. And then I'm going to solve. Now you have to be careful. Anytime you have a quadratic equation, I know this is quadratic because of the x squared, I have to set this equal to 0 and solve. So x squared plus x minus 1 minus 11 equals 0. X squared plus x minus 12 equals 0. And to solve this, there's lots of ways I can do it. I can factor this one now. I need factors of 12 that when I subtract them I get 1. So it's going to be x plus 4, x minus 3. Set each factor equal to 0 and solve. So when I do that, I get 2 answers. Now here's the deal. I have to figure out, are both of these my answers or just one of them? Remember, our answers, our x values, have to fall between this closed interval, between 0 and 5. Negative 4 is not in that interval, so I automatically know they don't want that as one of my answers. X equals 3 is my answer, or you can call it C. Okay, so what does that mean? That means when x is 0, the height of my graph was negative 1. When x was 5, the height of my graph was 29. Okay, so that means I'm guaranteed a number, and at x equals 3, my value is 11, or my y value is 11, which falls in between those two values. Let's do another one. Verify that the IVT applies to indicate an interval, and find the value of C guaranteed by the theorem. First of all, I have to say, yes, f of x is continuous. Alright, then I'm going to find my f of 0 and f of 3. That's going to be my endpoints, or the height. How far up, how far down does this thing go? F of 0. 0 squared minus 6 times 0 plus 8. That's going to equal, what, 8? Now I'm going to find my f of 3. 3 squared minus 6 times 3 plus 8. That's going to give me 9 minus 18 plus 8. So negative 9 plus 8, negative 1. So they're saying this graph goes down to negative 1 as far as my y value, up to 8. They want to know at what point is my height 0. So they're saying negative 1 to 8, so negative 1 is less than 0 is less than 8. This number right here. Now, if this number doesn't fall between these two numbers, something's wrong. We can't do that. So now I'm going to find the letter C, or my value of C, where my height is 0. So to do that, I'm going to take my equation, set it equal to this right here. Change colors on you. So I'm going to take x squared minus 6x plus 8 equals 0. I'm going to factor it. I need factors of 8, then when I add them I get 6. So it's going to be minus 4 minus 2. Set each factor equal to 0 and solve. So x equals 4, x equals 2. Now I have to check and see, can both of these be my answer or just one of them? It has to fall between this closed interval. So x equals 4 is too big, so my answer is 2. So when x is 2, my y value is 0. Alright, you have your worksheet that you're going to do, and I will see you tomorrow.